Welcome, everybody. Thought I would do a little dev stream for fun. Haven't done one of those in a while. And I thought it'd be nice to also try out this new time slot. Because honestly, it's going to work better with the schedule. I'm moving everything up to 6 o'clock. So, what are we doing? I thought about it back and forth a lot. Like, what game should I be trying to make from scratch? And I'm going to go back to a challenge that I do every so often. I come back to it, and you know, it was one of the first games that I tried to make myself. That I actually got any progress on, and every so often I just come back and I try to make it over again. So I'm going to do that, and I'm going to make it in the browser because if you want to follow along in real time and make it with me, then you can't probably because just about every computer is going to have the few tools that you actually need to do this kind of project. I do have a cheat open. I have an existing version of this project open on a hidden window if I need to check it. But I'm going to stop waffling on and get right into it. I'm going to make Tetris. And to make Tetris in the browser, we're going to have a few tools that you want to have to start with. First of all, you want to have a web browser. I want to say just about any browser will do. I prefer Firefox or Chrome because they have this nifty little debugging tool. You can inspect your markup, pay attention to console stuff, and even debug your the raw script they have in there. But anything will do as long as it's not really old, like Internet Explorer 8 or something. You want to have that. You should also have some kind of text editor, like a raw text editor. Don't open Microsoft Word or something like that. I like Atom and Sublime Text. I'm going to try to use Atom because Sublime Text, it's a very expensive to buy the license, and I've gotten kind of sick of clicking away that little prompt that comes up every 10 minutes or so. So Atom is pretty good, and it's free. You can just go grab it if you want. Sublime Text is also free, kind of, although they want you to pay for a license. Or Notepad++ is another good one, just about anything that allows you to edit the pure text of a file. Stuff like Microsoft Word and like I think Mac OS has Notes app or something like that. You don't want those because they'll add a bunch of extra stuff that will not work. The last thing that is good to have but you don't strictly need is a shell terminal app, like a command line. I'm gonna actually navigate to the right directory, or you know what? I'll instruct on that, and I'm gonna go assuming that anybody following this tutorial is going to be using a shell. So in Windows, PowerShell is a good one. You can just hit the Windows key and type in PowerShell, it'll come up. If you're on Mac OS, you want to use the Terminal app. That one will come with your system. You can just, command space and then type in terminal. It should be this little black box icon with green text in it. And Linux users probably are familiar with the terminal. I would be surprised if you aren't. So let's get into it. First thing is we want to change directory, that's CD, into whatever directory you're going to be using. I have this projects directory that I use, and I already have a folder that I call Tetris HTML2. Let's go in there. There's nothing in Tetris HTML2. And the last thing that we're going to do, we're not even going to use the terminal all that much, so don't worry. This is the last step. If you have a terminal, you might have to install Python if you're on Windows. And this is why this is not strictly necessary, because you can, I'll explain why later, but if you have Python, which you will on macOS and probably Linux, you can run a command like this. Server And this will mean that you can go to this port in your browser's localhost, and it'll show up. It'll basically serve whatever's in this directory. Um, I'll explain that as we go to it. But for now, if you have Python, run that and we'll all be set. If you don't have Python, don't worry, I'll explain your alternative. First things first, we want to have a new file in our folder. Oh, that's right. I can just type out. So we're going to call it index.html because that is the standard HTML way to do things. There we go. Nice thing about editors like Atom is that you can see the file structure. So we have our folder and index.html here. I'm going to use the autocomplete that Atom gives you. This is a whole lot to take in, I know. But we've got our modern document type flag at the top. HTML. This is our HTML markup. And at the top and bottom, we have the tags that wrap the entire document and tell us, what's in that content as HTML. These things, I don't see these all that often, but they're provided with the Atom autocomplete. You don't strictly need them, but these are sort of accessibility properties. Excuse me. We have our head tag, which this is stuff that will be invisible to users in the browser, but it tells us it's very technical stuff. Like these meta tags are usually very technical things. One thing we're going to put in here is the title of our page. I'm going to just call it Tetris. I'm going to put some other stuff in there in a minute, but first, just to make sure that we're going to do a sanity check just to make sure that this document is working and Python is serving up the page correctly. The body tag is where all the content that you actually see goes. Let me rephrase that. The body tag is where where all of your content that will be visible on the page is located. Funky grammar shouldn't be too hard to follow, but we're going to put in something simple here. We're going to just put in some text like, hi there. And now let's swap on over to the browser. And I'm going to change. So here's where things change. If you don't have Python running, or you don't want it to run your server, all you want to do is just open the file, go into your browser and open the index.html that you just made, and it'll look something like this. It'll have, file : and then your local directory to the file. But if you have Python running, what you want to do is local host like this, :8000. And what we should see, if I did this right, we should see some text coming up. It's very slow. You know what? I'm going to open a new tab and see if it works. Because that animation has been running for a while, and it might be doing something funny with memory leaks or something. Oops. 8,000, 9,800. Okay, this is where we get into our debugging mode. Maybe I have to restart the server. Oh, there it is. That was weird. Maybe it'll be fine. If I refresh the page, does it load? Okay. Sorry if that's a little blinding. It's a bright white background on what has been so far a very dark screen. But you can see our text, the text I typed in there, hi there. That's our index.html document. First thing I'm going to do is I'm going to add a style sheet so that we don't have to see that bright white background. It won't be so jarring. So we're going to make another new file. I'm going to just call this styles CSS. Keep forgetting that Atom doesn't like to do the thing that Sublime does. Getting used to it. Excuse me for a second. All right, so here we go. First things first. We can do stuff in our index.html to change colors of stuff, shape things, and so on, but it's better to separate that out into a separate file, which has the sole purpose of defining our layout or styles. So we're going to do body tag. This is how we define styles in cascading style sheet format, which is what CSS stands for. We're going to say the background is, let's do, I did this earlier, I think 102 looks pretty, or let's see, 1F. That's a nice color. This is hex code for color. You can also use, you can also type in, if you want, you can just say like navy. There's some color keywords that work, like white and black are pretty reliable. But if you want a specific color, then you want to put in a hex code or RGB, which you do like, oops, you type in RGB and then you do number, and you can do alpha if you really want. I won't get into this too much. I'm taking too much time on the granular details of stuff that is not related to the game, so let me stop with that. We are going to do a little more styling in a minute, but for now, we've got hi there. We won't be able to see it because it'll be so dark, but if I go back to the page and refresh it, oh, that's right. It won't show up because I made a style sheet and I didn't actually attach it to the page. So you want to have a tag called link, which we can put anywhere on the page really, but if you put it in the head, then it'll get loaded before the rest of the page does. So we're going to say styles. CSS is our high reference. That's what that stands for. And I'm going to put these slashes because I like to have those in tags that don't have closing tag associated with them. So style CSS, it's going to look for this file in the same directory. And so now, when I reload, when I go to Firefox and reload, there we go. We have our dark, very, very dark purple background. So that's just an example of how style sheeting works, and we're going to use it a little more in a minute. To set up our game, we need a special, we don't strictly need it, I guess, but we need, actually, I guess I could just do this, can't I? We want something called a canvas. This is an HTML element that is designed to allow you to just draw anywhere in it, and to draw frequently if you really need to. We could use HTML, we could have like one HTML element like per object that we want on the screen, but then you would have to load an image in it, or you would have to do some crazy stuff to draw what the contents are going to be. Canvas is a great thing to use. That's what you want to do. You want to use this if you're making a game. Now, maybe I should have started with this, but for this game, I'm going to go the extra mile and do some fun kind of retro styling, which is to say that I'm going to make it a very small Tetris board, scaled up and pixelated, more or less. So the height and width is in pixels, and we're going to have a width of 40 and a height of 80, I think. Yes, that's right. So a Tetris board is 10 tiles wide and 20 tiles high, and we're going to have each tile be only 4 pixels by 4 pixels in size. So we define our size of our canvas that way. Here in the styles, we can tell our document that we want our canvas to be fixed position. I'm going to type all these out first and explain them in a second. How wide do we want it to be? Let's do 200. If we do a round, if we do a multiple, if we do a multiple of our initial canvas size, then the pixel scaling will be will line up really well. So that's right. We want. Oh, you know what? I usually put top at the bottom. I usually put positioning after other stuff. And I'm designing this to be. This is a web development trick to get your No, 200 pixels, that's right. This is a trick to get your elements to be centered in the window. Of course, this is not great for responsiveness. Like if you're on a smartphone, you're not really going to be able to play this. Suffice it to say, this will work for our purposes. So let's see. The one other thing we want to do is we want to have this special field called image rendering. Oops, and I put an underscore by accident. Pixelated. Adam really wants to autocomplete all this stuff for me, but I'm going to type it out for the most part. So this is going to prevent the browser from trying to, it's going to prevent it from trying to, what's the word, to blend the pixels. It's just going to do like nearest neighbor scaling. So rather than trying to blend the pixels together, it's going to just scale them up 1-to-1 so that everything has this pixelated look, more or less. From what I remember of doing this project earlier, it didn't really look all that pixelated, but that's just the way that I ended up designing it. So the last thing we want is script.js. Oh, never mind, I'll just make a new file and save it and then type out the title. This is where the main body of our game is going to be and where we're going to be looking most of the time in this project. These two files we're not going to look at too much anymore. I am going to put in a script tag, which we're going to say src for source is going to be script.js. And script tag is one of those tags that you can put stuff inside, but we're not going to put anything inside because we're sourcing a file. Our script is going to be entirely in here. Right, and so, let's see, let's get into it. So with the canvas, first thing we want to do to actually draw on the canvas is we want to grab it. So we're going to do canvas, and we can name it whatever we want, but I'm calling it canvas because I'm uncreative, as evinced by me creating a game that already exists. No, that's not right. Canvas.get context 2D. I like to use double quotes, even though I know in JavaScript you can do single quotes and it's effectively the same. At any rate, this is how we do drawing things on the canvas. So we want to get the actual canvas object in JavaScript. We want to be able to reference it, and get context 2D will give us a 2D drawing context. I think it's render context 2D is what it's called. It's designed and optimized for only rendering in 2 dimensions, which is all we need for Tetris. So now we have that. Let's actually draw, let's actually do a draw command to make sure that we're not crazy. Let's do clear RECT for rectangle. And we can, because I maintained canvas as a separate object here, we can call, oops, canvas width and canvas height. And we can clear the whole rectangle, even though we don't strictly need to. And we can do fill rect. And I'm going to say, let's about 20, 30. And we'll do 4x4 because that's how big our tiles are going to be. And before I forget, we got to say what the fill style is going to be for that rectangle. Let's do triple E, which is close to white. So clear rect, it just takes a rectangle defined by x position, y position, width, and height, and it basically clears all data from the canvas. It will render whatever's in the background, or you'll see whatever the background color of the canvas is, which could be transparent, it could be black, it could be any. That's something that we could also define here in our style sheet, but I'm not going to bother because, well, you'll see. It'll make sense later. Fill style, I'm not going to use it too much because I actually have a more optimal way, I think, of doing colors. This is another hex code, which we can do in either the full 6 digits or 3. It'll double up these letters, so this is the same as 6 E's, and I'm doing 3. And then fill rect is similar idea to clear rect. We have X, Y, width, and height, but it'll use whatever fill color we define here. This can be kind of clunky because every time you want to draw a rectangle, you'll have to redefine what the color is unless you're drawing the same color again. We'll come back to that later. But so far, we have all this stuff. I have attached the script down here. I might make a little space around here just so that it's easier to see things. That looks a little nicer. I don't know, maybe it's too much space. I like to have some lines, some new lines between things. We can include the script, by the way, inside the body or out. It doesn't really matter, I think. Unless I do some extra stuff in here, we have to have the script after the body tag, or at least after the canvas tag, because the script will run right away, and if we put it up in the head, then the body doesn't exist yet. We can't grab this canvas because the canvas doesn't exist either. So this should be just a little sanity check that will draw an off-white rectangle inside the canvas, and we'll also get to see where the canvas is. Our text in the window should be gone as well, in the browser that is. So let's go back here, refresh, and there we go. We've got, clearly the canvas is transparent because we should see this big, tall rectangle here, but we have this little white square drawn where we told the canvas to draw it. Good, everything's working. So let's go back here, and we're not going to bother with this stuff for a little while. The next thing we need to do is we want to define... Okay, so we want to define a function that will draw tiles, like any tile that we want. So let's say draw tile, and we're going to pass it a few things. We're going to give it the oh no, that's right. Here's where the kind of old school, maybe optimized drawing thing comes in. So we're going to call it draw tile because it's going to pass data to the canvas, but not actually... I'll explain it as we go along. Okay, so first of all, draw tile, we're going to do a lot of funky stuff here. The first thing that we need is we need our X and Y positions. All the tiles are going to be the same size, so we're not going to bother passing that to that function. We're also going to do, I think it's image data, which I'll explain in a minute. So, before I get into this draw tile too far, no, you know what am I saying? Okay. Before I get into it too far, I'm going to define what this image data is. So this image data object is a collection, like a long string of numbers, or an array, I should say. It's a long array of numbers, a collection, that defines each number defines part of the color in a pixel on the canvas. And we're going to be very efficient, maybe, in how we draw this stuff. Because what we're going to do is we're going to go with each number in the image data and update it manually instead of doing the draw rect and those functions. So for that, oh, you know what? Draw tile is also going to need a color. I'll do that later. But for this, what we need to do is for... oh, is that coming in through? Somebody's revving their engine outside. I hope that's not coming through the mic. Anyway. Yeah, it's very loud. So, for image data, here's how we access our array. We use square brackets, and the numbers range from 0 to however big the canvas is times 4. So the number of pixels on our canvas is going to be the width times height. That's going to be 3,200, I think. Yeah, that's right, 3,200 pixels. But each of those pixels has 4 numbers associated with it. It has a red value, green value, blue, and alpha, which I think alpha runs from 0 to 255. I might be wrong. The red, green, and blue run from 0 to 255. Not sure about the alpha. Might only go from 0 to 1. But we're going to access these directly by doing some math. So our X and Y position is going to be, so we're abstracting this stuff. X and Y position is going to be in terms of the grid, where we only have 10 columns and 20 rows, because that's how Tetris is built. So our X value is going to be from 0 to 10, and Y will go from 0 to 20. That means that we have to convert from our abstract grid positioning to the literal pixel positions. That means that the let's say this is the image. Let's call this pixel. No, that's not right, because the pixel encompasses 4 numbers. We want to have like a data index. So this is going to be the index number in our image data collection. And our starting index is going to be pretty simple. We just want to have x times 4, and then we add y times, we have y times 4, is that right? Yeah, we have y times 4 also times canvas dot width. Because this is just a single dimensional array, which means that it starts from the top left and it moves 1 pixel to the right until it hits the end, until it hits the right side of the canvas. And then the next pixel is going to be back at the start, back at the far left, but 1 pixel down. You can think of it like a typewriter, where you type, and then you thrust the thing all the way over to the left once you're done with a line. Or, you know, when you're typing, right? You go 0, 1, 2, 3, 4, and then enter 5, 6, 7, 8, 9, enter. This is what our array looks like, except the image data, all it sees is 0, 1, 2, 3, 4, 5, 6. It doesn't see where the next row comes in. That's why we have our X position and Y position split up like this. But this is the compressed version. The row is going to be, you know, y times 4 times canvas width is going to be the start of the current row we're on, and then we add x times 4 to get from the left over to whatever pixel we're looking at. So if we have a tile at, let's do this as a comment. If we have a tile at 3, 4, that's column 3, row 4. Row 4. And that has to translate to pixel, because we have 4 by 4 pixels, that has to translate to pixel column 12, pixel row is at 16, and that has to translate again. We have to add the data index is going to be, you know, 12 times 4 plus, you know, 12 times 4 RGBA values, and then 16 times 4 times our canvas and width, which I think is 40. Yeah, width is 40, which means our end value with this is going to be, let's see, 48, 64, 112 times 40. There's a lot of maths. 480, I think that's right. So we get this massive number, which is going to point to the red value in our image data. And then 4481 is going to be the green value, 4482 will be blue, and 4483 will be alpha. So we're not going to bother with alpha, so we're going to skip it. But we're going to bother with R, G, and B. So let's see. So our image data, we're going to do a little loop. Oops, what did I do here? I switched into a different pane. Excuse me. So for, let's see, right. So for each row of the tile, this is where our abstractions get kind of complicated. We have to kind of scan, we have to do kind of scan lines drawing each row. We have to do each pixel in a row of our tile, and then each row of the tile. Again, think of typing where you're doing like you know, if you're doing ASCII art, you have to do, and then do, and then do, and then you have a square, sort of, a rectangle. That's what we're doing right now. But it's even more granular because with each of these, you know, pixels, we have to pass 3 values. So I'm going to start with this word row. We're going to say row equals 0, row less than 4. You know what? I'm going to say tile size because we want to have a constant called tile size. And I'm using some backwards compatible language here. I could use the constant keyword, but I know some older browsers don't support constant, but do support canvas. So I'm trying to maximize compatibility with my language writing here. I won't explain it too much more than that. Let's also remember our curly braces for loops, for code blocks, really. I haven't finished with this though. Row is less than tile size and row plus plus. And then we need another for loop for column, which I'm going to shorten to COL. Col is less than tile size. Col plus plus, and this. Before I go any further, actually, we should have tile. So tile should be an object that contains some constants like size. For easy reference, we're going to put more stuff in this tile object. But before we get too far and have to start rewriting lots of code, I'm going to do this. And it'll make more sense as this function gets built out a little more. So we've got our tile size, row, column, 0. It's 4 by 4, so we can use one number for our tile size, the row, 4 rows, 4 columns. So we're going to start at data index. And I'm going to do something kind of funky that may or may not work. I think this does work. And I'll explain it in a minute once I'm done. So we're going to do, let's make this a white tile again. We're going to do 255. And then we're going to do data index plus plus again, and that should be okay. So what we're doing here is this plus plus operator. This is the increment operator. Putting it after the after this variable selector, this variable label. I always forget what the term is for the actual name of a variable. At any rate, putting this operator after this number means that image data, this gets evaluated first, and then this number gets incremented 1 after the fact. So if this starts at 0, this whole evaluation will be, you know, image data 0 equals 255. Then image data, you know, equals image data plus 1. So putting the plus plus after this means that we get this order of operations, but all of these expressions get evaluated in this one line. It might cause problems if you aren't familiar with this sort of thing, but I think most people will recognize, most programmers who are familiar with, oops, didn't mean to close that. I think most programmers will recognize this syntax. This goes back to C programming language, so very standard stuff. Also after, I screwed this up. This needs to go up here. Oh, glad I caught that. So for each row, we loop through the full line of column, the full number of columns, and we take the red value, add 1 to go to the green value, add 1 to go to the blue value, and then we add another one because we're skipping alpha. Alpha should always be 255 or 1, whichever is full opacity. I'm going to make sure that's the case as well, because I think by default the canvas renders as an empty canvas. Maybe we can just do this. Maybe it's as simple as background triple F, which is white. That would mean that it's also opaque white. So here's our draw tile, and we're assigning values to the image data. Now image data, this in itself will not actually do anything. Because what we need to do to actually draw a tile with image data, let's say column 1, row 3, excuse me. To actually draw a tile, we need to pass the image data in there. So we're going to make an image data. We're going to get the image data object from our canvas, from our context. That's right. I think it's just get image data. I think that's right. This works like the rectangle function that we saw earlier. Canvas, right? There we go. This gets the entire image data of the entire canvas, the entire array from 0 to whatever I said it was, 4,480 values, I think. Something like that. So we get the whole image data from the canvas, we pass it to this draw tile function, it changes the values, and then we call, I keep typing canvas, we type context dot put image data, and I think we can just do like this. We can pass in the image data and give it the x and y coordinates. I think we have to give it its width and height when we get the image data, but putting it back in, we only have to put in the x and y position. Because this is a way to draw, this is a way to grab part of a canvas, mess around with just that part that you grabbed, and then put in a new part like anywhere you want. You could like superimpose stuff. If you wanted to be really clever with this, you could just draw a rectangle and then smear it across the screen in whatever pattern you want it by, grabbing the image data at that position, updating your position, and then like putting it back in a new one. You could do all sorts of creative things. This, though, should be a way to draw a 4x4, since we said tile size is 4. Should be a way to draw a 4x4 pixel tile in the first column, third row. And since you know what? It's a white tile. So let's actually make this black. Full zeros is black, but it's also opaque black. And we're going to put on a white tile. We should actually see a black, kind of a black tablet shape where our canvas is this time. Unless I typed in something wrong. This all looks correct. The plus plus operator works here too. We're not using either of the row or column variables, but if we were, they would stay at their initial 0 for the first iteration of the loop and then get incremented. And the loop ends when this condition is met. We're doing less than tile.size, and that's good because I believe if the order here is a little confusing because I believe this condition is checked. Oh no, you know what? I think this condition is actually checked before the loop even starts. So 0 is going to be less than 4, so we get out the first. Anyway, it's something I haven't really thought about. You just sort of learn some of this syntax and you go with it. In practice, it works, and so you don't think about it, you don't change it. So let's go back to the browser. I'm going to refresh, and this cube should be gone. It might be up over here now, and we'll see a big black rectangle unless something is wrong. Ooh, that's interesting. So we got our big black rectangle, but no tile. Ooh, that's why. I typed something wrong. So let's go back. This is why the console is so important. I think Safari and Internet Explorer and Edge, which is just Internet Explorer in disguise, don't be fooled. They also have consoles like this and debuggers where you can look at this stuff, but I think with Safari you have to install an extra thing or enable a setting, and I don't know what you have to do with Internet Explorer, but probably it's some like ancient black magic. You have to make a pact with like an eldritch god or something. So Firefox and Chrome are good to go. Are good ones to pick. Maybe Opera, if Opera is still a thing. Anyway, back in here, I screwed this up. This is the wrong syntax for objects. You want to use a colon. You want to have your property name followed by a colon. You can put it in double quotes if you have spaces and stuff, but we don't have any spaces, so put our colon there to delineate that the value is 4. Now let's go back to the browser, and this time, here we go. The only thing we got is we're missing our fav icon. But we also didn't get a drawn object, and that's interesting. I wonder why that is. Excuse me. Luckily, we have our debugger, so we can do context get image data. We can just call this method right here. Canvas width, canvas height. Cool, and it's a pretty big array, as you can see. But let's see, let's do the math and figure out where this would be. I said 1, 3, so it's gonna be 1 times 4. I guess the shortcut is 16, right? 4 times 4 is 16, so we've got pixel position 16, and then 3 by 16 is 48, so we should be looking at 48, let's just type in 48 by 16, 768. So we want to find our 768. We're just going to be way down here. 768 should be the starting position. And yeah, look at that. Didn't actually update. That's interesting. So let's go back and check our code. One of the frustrating things about a language like JavaScript is that just because we pass this image data into the function and modify its numbers doesn't mean that we actually modify the object outside of the function call. We should, though. I don't know why we don't. Well, that's another use for the debugger. So I have a sort of kind of a brute force option, if you will, that will make this work. That will force this to work. But instead, I'm going to put in a break point, and we're going to actually take a look at what the image data looks like. Okay, cool. So we got our image data. That's interesting. So we have some numbers that have been set to 255. Let's see. Data index is 47. Oh, our data index is the wrong number. I mistook. I assumed it was a different number than it actually is. It's 400. So I did the math wrong. Oh, that's right. I multiplied both by 16. Never mind. So this is 487 is going to be because we haven't run plus plus yet, 487 is going to be, I want to say the index for the blue value at this pixel. Column is at 0 and row is at 0, I think. So we can actually see that. Right? Where's the context for our scopes? Here we go, window scope. Oh no, local scope. So we have column 0, row 0. Our data index is 487. Image data. That's interesting. Image data looks like it's empty. Oh, I forgot. So image data has a nested value that says data, and it actually has the width in the image data. So I was wrong. The image data does know how wide and high the canvas is. So we actually can improve our script a little bit. Calling the canvas width is pretty far out there because we're calling a global object that can actually take a bit longer to process because you're looking at the global namespace, you have to look through all of the objects and then grab it. So this should work. The data property of image data is our numerical array. It says it's a uint unsigned integer clamped 8, I think. So it's an 8-bit clamped integer array. So if you add a value that's bigger than 255, it'll clamp it down. And if you add a value that's less than 0, it'll clamp it up to 0. Because it's unsigned, which means that it's always a positive number. And it's an integer, which means no floating points, no decimal values. This should be correct now. Let's go back. Let's take a look. If it's not correct, then, I'll eat my words and I'll have to do something else. Ooh, interesting. It may be correct, but it's still not doing it. So why is that? We're not getting any errors, so I'm going to reload the page to run the script again. And let's see, we're at image data. So image data. So we know our index, so we can actually look at this image data object and grab the right thing that we want. Scroll down to, what was it, 487? So around 487, here they are. 484, 485, and 486. Okay, so I guess 487 is after the plus plus has been evaluated already. But these should be our red, blue, and green values for the pixel that we're trying to draw, which has been scaled up, by the way. Like, this is a scaled up rectangle of the 40 pixels by 80 pixels canvas, or it should be. I think so. This looks bigger than 40 by 80, yeah. What am I talking about? So I'm going to put a second, I'm going to close this breakpoint and put a second one down here because I want to see what the image data is after this function runs. So let's proceed to the next breakpoint. Cool. Now we've got our image data. Let's look at 488, 486, and 7. Oh, look at that. See, they're updated. Image data. Maybe we actually have to... the nice thing about this as well is that we're still kind of within the code execution. We can just call that function again. So maybe we actually have to context, no, not content, context. Maybe we have to put image data. Maybe we do have to have the width and the height. Maybe I was wrong. Canvas width, canvas height. I guess technically I don't have to maintain the canvas anyway because the image data has its width and height, but whatever. Let's see if that works. Image data, 5 is not a valid argument count for any overload. Oh, okay. Here's where I turn to the internet. So we want to look at MDN, put image data. Because I think I've done something wrong. And when I've done something wrong, it's time to go look at the documentation. So this is right. Image data. That part's right. What we want to do is get image data. What is this one? Yeah. Top left corner. Width and height. So this is all correct in the script. This should be all correct. Get image data, we draw the value. The image data is getting modified, so by the time we get to this line, the image data has been changed. But for some reason, we're not seeing it. What if I do this again? No? Very strange. Very strange. I want to see how this compares to my... This is why I have a separate, like a cheat sheet, effectively. I want to see how this compares. Oh, you know why? Well, we should be seeing something. There was a part that I forgot, but we should be seeing... We should be seeing something rendering on the page. Excuse me while I check my notes. Because the trick is that this render tile is potentially more efficient, but it does mean that we don't actually draw anything until we try to put the image on the page. It's so weird because my other script, my other version of this does work. Let's go back to the script and see if I can't make this happen. Because I think maybe I do have to actually clear... Yeah, let's try this. It's possible that the alpha value is just 0, and despite doing this, despite setting the background in CSS, it's not actually working. So we're going to remove that so that the canvas is transparent. And I think the first line we're going to have to actually do is we're going to use those functions I said we weren't going to use before. So we're going to do fill style equals opaque black. Then we're going to do context fill rect 0, 0, canvas, excuse me, canvas width, canvas height. So this will make sure that the canvas is filled with opaque black at the very start, and then when we actually try and grab image data, the alpha, we won't have to modify it. We can just increment again and go back and go past it. I'm actually going to leave this as it is so that you can see my mistake and what it looks like. And then that can be a teachable moment. I think we can experience what that looks like. Here we go. So we have this really, really wide bar, which is not right at all. But there we go. This I wonder why it looks like that. But we'll I'll fix my mistake and we'll see. So it should be making a cube, but it is not. And that's because we're just incrementing the data index in a straight line. We're not actually going to the next row. And that's why we have to go down here and we have to say data index. And we have to add image data. Oops, no, I had it right before. Image data width. We have to add 4 times the data, the width. And then we also have to subtract 4 because, well, we have to subtract 4 times the tile size, I should say. But I'll explain. I'll actually, you know what? This will be another teachable moment. So if all we do is add the width of the image data multiplied by the number of our RGBA values, the number of values per pixel, which is 4, I should say RGB and A. If we just add that width, then let's go back and we'll see what that looks like. Boop. And so we get, to the end and we add the next row, and then we get to the end, we add the next row. That's not what we want either. But we're getting close. So the way we fix that is we do this line that I commented out. I shouldn't have written this first, but I was thinking ahead. So we subtract the tile width multiplied again by our number of values per pixel, which is 4. Now we go back. Whoops. Why do I even have this open? Silly extra windows. It won't even show up on stream. I don't know why I'm reacting to it. Okay. There we go. Now we have our cube, which is in... oh, you know what? It's in pixel position 1, pixel row 3. Pixel column 1 and row 3. So we're not quite right. The last thing we need to do is we need to multiply by the tile. We need to put the tile size in here. So we're going to do x times, oops, times tile size, which we can do that. Oops. Nice little keyboard shortcut to capitalize stuff in Atom. And tile size that. And now the starting position should be translated from our column row system into literal pixel positions. Because that's the way I'm building this. I'm building this very old school where we're not going to even animate, we're not going to smoothly animate across the whole space. But I've refreshed the page and you can see we've got this one column space, and you're going to have to trust me that that's 3 rows of space above the tile. We're coming up on an hour and I've barely done anything, so let's see if I can speed up the process a little. So having done that, you may wonder, why did I bother even doing all this? Look at this. We're grabbing the image data, we're just drawing one tile and going back. Well, we can draw many tiles and then put the image data once, and that actually saves a lot of processing power. Before we go any further though, let's actually come up with some different tile colors. So we're going to say, a good thing to do when you're doing this kind of low fidelity pixel art is it's good to have a border, border, and a fill. And we can actually keep this really simple. We're going to have an array. Actually, I'm going to have an optimized one. I'm going to say new unsigned integer array, which I think we want to say 8, because these values are going to be basically equivalent to these image data values, 0 to 255 for red, green, and blue. And I'm actually just going to copy over what I already have rather than typing it up again, because I came up with some nice colors. So let's do this. And I'm going to go in here. I'm going to type in that. There we go. So these colors, I wrote up some hex representations and then translated them. So this is going to be kind of gray, this first row. The next row is going to be kind of a red. Then we've got green, blue, orange, kind of cyan color, magenta, and then, oh, not orange, yellow color, cyan, magenta, and then an orange. And the border colors are a little darker. So we're going to modify this. We're going to add a color index. I'll just say color number, or number. And we're going to put in 0. 0 is going to be the first one. We always start from 0 in programming. And of course, you'll notice that I've arranged these as rows, but much like with our image data, this is just a one-dimensional array. So we're going to have to do some more math to get the actual color for each one of these. So we're going to say color index, which this is going to be the starting color index. This is going to be color num times 3. It's nice and simple. We only have 3 colors, 3 numbers per color. So we just do the color number times 3, and that's going to be either here, here, for 0 it's this one, for 1 it's here, 2, 3, 4, and so on. And then down in here, we're going to do some funky stuff. We're going to say tile, and we're going to say tile, we're going to say tile that fills, and then put in the index, which is going to be color index, but here it's going to be +1 and +2. We don't want to use the incremental operator because we want to start with the same color index each time we draw a pixel. So now we should be getting the fill color, which is going to be any one of these. Let's go with blue, which I think is 3, index of 3. So back in the browser, if I refresh, this should turn blue, and it does. Magic. So here we go, back in Atom. The one other thing I'm going to do is I want to draw a border that is the top row is going to be the border color, and the far left column is going to be the border color. So what we're going to do is actually, we're going to use some JavaScript magic, because we don't have to use dot and then the property name, we can use strings. Might be a little less efficient, but we're going with what we get here. This is more clean to look at. So we're going to say, we're going to put borders in here as well, and we're going to use a ternary operator to decide when to use one or the other. So we're going to say row equals 0 or double pipes col equals 0. So if the row number or column number is 0, we use the border color. If it is not, then we use fills. So let's go back to the browser. I'm going to reload this, and we should get a nice darker border on the top and left to give it a little shading look. And there we go. That also gives us an idea of how big the pixels are, because this is only 1 pixel wide in either direction. So back here, let's pick up the pace a little bit if I can. We're going to leave this in the global scope because that's going to be fine. At some point, I might wrap this in a closure just so that it's that tiny bit more efficient, but for now, let's move on. We've got our draw tile, so what we want to do is come up with a tetromino object. And of course, I'm going to use this old syntax for declaring classes because the new syntax has all these problems. I'm not going to get into it, but it's better this way for my purposes. For game development, it tends to be better this way. You have to do a lot of binding and, recreating functions and stuff. Because JavaScript is very annoying. Moving on, tetromino. We have some properties on the tetromino. We're going to say, we're going to give it an X position, a Y position. Oh no, that's right. Here's where we optimize things. We're just going to give it a set of tiles, which is going to be, I'm going to define in a minute. Because normally you would give it an X and Y position. You can move either of those numbers and it'll move around. Not the way we're going to do things. I'm going to make it a little optimized unsigned int array again. And it's going to be, I guess it's just tile size, isn't it? Oh no, that's not right. We do tetromino Is size appropriate for Tetronimo? Let's say tile count. There we go. And then, of course, we want to define what the tile count is for Tetramino. There are 4. 4 turns up as a common number a lot in Tetris, as it turns out. So tile count is going to be a constant on our Tetramino object, or Tetramino class, and we can call it here and say, hey, look, there are 4 tiles in the tile count. We also want to define what those tiles are. So in my mind, in my lexicon for Tetris, tiles refers to the squares in the Tetramino, but also the squares on the board, the squares on the game board. So Tetramino is made of 4 tiles, 4 squares, and we want to initialize the Tetramino with a random selection. And here is how I define the Tetramino shapes in terms of tiles. So each of these is an index number that indicates Tetramino's position on the board. And now that I'm looking at it, I should probably make the board first and explain how that works. So let's move on to the board. The board, Tetris board. We're doing this the same way. This is going to have tiles as well. That's going to be a new unsigned integer array. I guess it is on lowercase I. Well, anyway, I always forget if it's upper or lowercase I. Unsigned integer 8 array. The length is going to be Tetris board dot tile count, because we're also going to have a tile count for the Tetris board. But this one is going to be Tetris. This one is going to be canvas. Oh no, that's not right. Gotta slow down. This is going to be defined by the width and height of the board in columns and rows. We're going to have width equal, width equals 10 and height equals 20. So multiply those together and we get 200. We do want to keep track of both of these separately as well, and we don't want to have to multiply them together every time we want to have the tile count. So we have that as its own number. So we initialize this. This is going to be an empty array of zeros because the Tetris board starts off as empty. And when you add a tetrameter to the board, this tiles array, instead of having an x and y position, this tiles array is going to tell us where each tile of the tetramino is on the board in reference to this big old array that is snaking around, row by row by row in just a one-dimensional array, kind of like what we were doing with the image data, where it just gets to the end of the row and it starts over. So with our tetramino, I think we want to just initialize it as a random shape. Now, you know what? I'm going to give it a shape to start with. We're just going to ship shape. We're going to give it a shape, and then we're going to do a little simple for loop. I have to actually give it a name. And we've got tetramino tile count I++. And we're just going to loop over the relevant tetramino shapes and just pass them into the tiles. So actually we want to do this tiles I equals tetramino shapes. And then I guess we should do shape index. We should do the same thing that we did up here with the color index. We do shape index equals shape, which shape is just going to be a number from 0 to whatever, and multiply by the tile count. Hey, young Daggerich. Yes, that's right. I'm making this is a kind of a little ritual I do every few years or so. I come back and I try to make Tetris from scratch. And I'm having a little fun trying to access the trying to do some typecasting as much as you can in pure JavaScript, or vanilla JavaScript, I should say. So, hang on here. We want to do shape index plus I, not plus 8, plus I. So there we go. Our shape index is going to be, if we have shape 0, it's going to start here, shape 1, 2, 3, 4, and then each iteration we go through from 0 to 4, we get the next one in the row. And I've already figured these out. These are going to be the starting positions of each shape based on where they fall on the Tetris board. And then moving them is a whole other thing, but I'll get into that in a second. So we've got our Tetris board and we've got our tetramino. We've got our tetramino. So let's actually move our tile drawing thing into the tetramino. So we're going to do tetram, prototype, render. Oh, you know what? We shouldn't say render. We should say draw, because rendering happens at the very end. And we're going to have our render, I have our image data. Yeah, thanks, Young Direch. I don't know how many times I've made Tetris. It's too many times. One time I actually made it kind of themed on the periodic table of elements because I'm a nerd. And that was fun. But I usually just keep it simple, like I'm doing now. Let's, okay, here we go. Tile count. Oh, I already have my conditions. Hope that car alarm isn't audible. I almost said legible. Hope that car alarm isn't legible for all of the reading out there. Yeah, simple. Simple in the sense that this is entirely, I don't have any image files that I'm loading or anything. This is entirely rendered with JavaScripting elements. And the code is actually less than 500 lines, I think, when I looked at it. But here, now that we've got this draw function, we don't have to, you know, manually put in our row and our column and our color and all that stuff. Well, we do have to put in our color. I'm going to have to, I think our shape is going to correlate to colors. That's right. So shape, let me do that before I forget. This dot color is going to be shape +1 because 0 is going to correlate to an empty tile. This gray color is going to be what our empty tiles look like. And then shape, shapes, there are only 7 shapes, and then I've got 8 colors, 1 for empty and 7 for the rest, excuse me. So we define our color index that way, and then we can, when we draw the tile, we can declare our color. So here in the tile, we want to do this dot tiles I. So the current tile that we're on, oh, that's right, thinking about it. So our tiles I tells us the column, it tells us the index. We have to break it down into columns and rows. So maybe this isn't actually the best way to do this. Is this how I'm doing it in my own thing? I think it is actually. Yeah. All right, so let's do the math. I'm going to break it out so it's easier to read. So let's declare our variables here. We're going to do var x and y. So x equals tiles, and then we can duplicate this and do y. So to break this down into columns and rows, we just use our little modulo operator, and we're going to do, is it Tetris? Yes, it's Tetris board.width. This is why we want to maintain the width and height, at least the width. This, and then we're going to do Tetris board, Tetros. Tetros, what is that? Tetris height. We have to do this extra little step because this is JavaScript, and JavaScript likes to convert things all the time. We have to say, no, no, no. Keep this as an integer and bring it down to the next lowest integer if it's bigger than, if it's got a decimal. So we got x, y, and now we can say, we can patch the image data, x, y, and this dot color, which is going to be this. This also, the this keyword is also a good reason why I'm using this older syntax, because this, if you use this syntax, the word this will always refer to our instance of the tetramino, the current tetramino that we're referring to. With the new syntax, it'll refer to whatever context this function is called inside of, and not necessarily the tetramino. It's a horrible thing. Context is one of the worst things in JavaScript, and it is a pain in the head. But right now we have our draw tetromino and everything looks great and beautiful. So what we can do here is we can remove this line and we can just make a tetromino. You can even do, you know what, I'm going to have a little fun. Math random. We're going to modulo tetromino dot shapes. Oops, tetromino shapes. Out. Length. What am I thinking? Standard JavaScript property for a collection. That'll be our shape number, except that we have to floor it again. I think. Oh no, you know what? It's times, not modulo. I'm thinking, I've been working in too many different programming languages, because you can do, math random is always from 0 to 1 as a floating point integer. And so we want to multiply it by the shapes and then floor it. And that should do everything we want. Oh no, that's right. Tetromino. Now that we have our tetromino, render it. Or I said draw, didn't I? We say draw. Draw the image data, and I'm going to break these out so we can see them. So we've got our tetromino, random shape, draw it, put the image data back on the page. The whatever shape we get is going to define where it actually appears. So now that we've done all of this horrible mess, which, trust me, it's much cleaned up from how it could be, we go back here, and instead of this little square, we're going to get some random color, some random Tetris shape that's going to be right up here, I think. Or we could get an unexpected token error. So I screwed up something on line 51. Again, good reason to be using a browser with a good debugging tool. Whatever you do. So what did it say? Line 56, right around here? What was I missing? Modulo. I don't see what I was missing. I'm going to check again. Oh, it was position 51 on line 36. Where's this unexpected token? Maybe this syntax is bad. You know what? I could do this. I shouldn't have to call this condition a bunch of times. So let's say, no, that's not a good thing. Color type, color name. When you're naming variables, you want to be clear about what you're saying. You don't want to have any ambiguity. Ambiguity. Stumbling over my words. Nope, not nom, name. There we go. Autocomplete. At least I think that's why, where the error is. Let me go back, actually. That's some good cleanup anyway. Oop, excuse the bright white. Oh, it's not happy with this. Oh, I see what I did wrong. I'm using the new syntax again. So when we declare this function, we have to say, so the draw, what we're doing here is draw doesn't exist on this object yet. We have to define what it is. And we're going to say function, and that should work. Right? Now we're going to get a little Tetris piece here. Is that right? No. I think I did the same thing on a different line. What line is that? 8313. Sorry, I'm going to have to blind you all again. Doesn't like this. Oh, unexpected open parenthesis. That's what it is. Did I not? Toronto math 4, math random. Oh. Why I'm making weird mistakes here. Let me actually show it. Tetromino equals new tetromino. I should know better. I think probably the first time I did this kind of challenge to make Tetris was 2005 15? It's been at least 6 years. Yeah, granted, I've done it different like almost every time I've done this. Okay, so we have improvement. Luckily, the debugger actually caught the error and showed it in the side panel here. So tetromino I spelled wrong. Tetramonio. Tetramonio. Just I like thin fingered it, I guess, because I don't have wide fingers. All right, we're moving somewhere. We don't see a tetromino. That's okay. Let's see what we actually got for our tetromino. Oh, it's all zeros. Did I not? Did I not actually? I mean, granted, if they are all zeros, then they should be in this upper corner. Also, the color is wrong. I'm making a whole bunch of mistakes. Let's go back. One thing I forgot is the shape's length is going to be the full length of this whole thing, rather than how many different colors, how many different shapes or colors we actually have. We've got to divide this by 4, or rather, because there are 4 tiles per shape, we divide by the tile count. There we go. Boy, you know, you can do this sort of thing for many, many years and you still make dumb mistakes like that. Granted, I still have to fix this other thing, which is that for some reason, make this array, and it all starts out as 0. Why is that? Because this dot tiles, looking at it in the browser briefly, yeah, this dot tiles, the tetromino tiles are all 0. Which they shouldn't be, because none of these are 0. Oh, maybe it's because the shape was wrong. Alright, now that I fixed the shape, maybe that'll fix everything. Survey says, almost. Almost. I think this is supposed to be a T, and the next row is not rendering. Let's take a look. Tetron. Wait, even, I guess I just don't want to type it in the right order. 415. Oh, no, it's supposed to be like an, is that an S? It's supposed to be a Z shape. But it's stuck on the first row. Okay. I've mistyped somewhere. So let's go back into our draw function and fix it. So the Y position should be... Oh, I said height. You know, I was talking about not needing the height, because you don't really need it as much as you need the width. The width is the most important because we're doing this crazy loopy thing that I've been doing, which technically saves processing power and memory size. There we go. So now and I can refresh and get like a new shape every time. Look, there you go. And don't they look nice and crisp? That's what you get with this pixelated render option. What was it called? I always forget. Because there's a different thing. This is a new thing, image rendering. This is a new CSS property that I haven't seen until recently. There's some older trick that you could use to get the scaling to work properly. All right. Progress. We've made progress. So now that we've done that, we don't want to have a tetromino out here in the open. We're going to give the Tetris board a tetromino. So we're going to say this dot tetromino. Tetramonio? Can I not spell tetramino? It's spelled like domino. But 4, because a domino only has 2 squares. Tetris board. So what we're going to do is we're going to give the Tetris board a draw method. And I've got to actually spell it correctly this time. Oh, you know why? I think, again, I'm just used to other programming languages where you don't have to assign functions all the time to declare them. It's very strange, is JavaScript. But again, I picked it because it means that anybody watching this can follow along on their computer if they want. What we're doing, we want to do tetromino draw image data. And we actually yeah. we want to have the context get image data and put image data outside of the Tetris board and anything else. They don't need to know about it specifically. So, right, and then I'm going to have, since this is initialized as nothing, I'm going to write a function called spawn tetromino, and I'm going to write it before we get an error message. Proto. I never learned why you have to declare a prototype like that. I was never quite sure, but it's the JavaScript way. So we're going to say new tetromino, and we're going to do the... Oh, I should have saved that code because I'm going to have to type it all up again. New tetromino is math for math random times tetromino dot shapes. Oops, I should have just auto-completed it. Here we go. Shapes times nope. All this stuff. Hello, tetromino. Right, I'll count. I'm trying to use Atom instead of Sublime Text, which is what I'm used to as well, so. It can be a little annoying with some of the key commands being different. Oh yeah, hang on. I'm gonna put the constants above, whoops. I like to have constants before function definitions. Because you can look, if you need to find your function, your constants, you can scroll up. Stuff like that. Okay, so now that we have that, we're going to have the Tetris board, which actually, can I put this, I'll put this up here, because this is going to be part of our render loop eventually. I can say board equals Tetris board. There's a new Tetris board. That's something else. There's some weird optional stuff, like technically you should have the parentheses to call to instance an object from a class, but you don't need it in JavaScript if there are no arguments to instantiate that thing. So, I don't know. Feels like a code smell, but that's JavaScript is very smelly in that sense. So okay, so image data. We can pass that image data into the board. Before we do anything else, though, we're drawing the Tetris tetromino piece, but we want to actually draw the board background too. So what we're going to do is we're going to iterate over the Tetris board tiles the same way as we did with the tetromino. And we're going to do I, oops, 0, I equals I. The world would explode. Tile count, there we go. We're going to have the same problem again because I should probably change this because technically the draw tile function has to convert these numbers from x and y positions back into an index number. But you know what? Actually, it's probably better to do it this way. If I want it to be really hyper, if I wanted to be really hyper efficient, maybe I could just pass in like an index number, a single number, multiply that out, and actually get what I need here. But splitting it up into columns and rows first makes sense because you need to drop it down each row and the conversion is going to be different. At any rate, we're going to draw our background board so that we don't have just a blank void where our tetromino piece lives. And how do we do that? We're going to do draw tile. There's a this tiles styles. Isn't that like a textile thing? Styles. I'm going to do image data. We're going to have an x and a y that I'm going to define in a second. There they are. We're going to do the same thing. Tiles I. Width. Luckily, things like the Tetris board width are effectively accessible from anywhere, so even though we've declared this function calling the Tetris board width before the Tetris board is actually declared at all, before the width is declared on it, it's still, we don't call this function yet, so that width doesn't pose a problem to us. Luckily. It's one advantage of JavaScript, I guess. Like if you're writing this in C, you would do these declarations, like the constants, the function, and then the names of the functions in a separate file, and then each of those would draw on each other if they need them. So like, we wouldn't be doing our function declarations before declaring all of our other objects. Probably it makes more sense even to pass down from the Tetris board into the tetromino what the width of the board is, but I'm going to do it this way even though it's a little sloppy. So that's right, we need math floor again. And I'm going to put space in here as well. There we go. Let's get rid of that extra white space. I'm going to put a space in here as well just to distinguish these expressions from each other. And now this should draw every tile on the board and then draw the tetromino afterwards on top of it. I guess if you wanted to be super efficient, which probably is the case on old, like on the Game Boy Color, not even Color, on the Game Boy Pocket, which is one of the earliest versions of Tetris, you would probably want to only iterate over the board once, and if the tetromino is in one of those positions, you would draw the tetromino instead of the, empty or filled tile. For now, we're just drawing whatever tile is here. Because the trick is, once the tetromino is no longer controlled by the player, once it's landed, its numbers will be passed into the tile, sort of. The color will be passed into the tile at the position where the tetromino was. And so this loop will always draw landed tetrominos. And whatever tiles are left over after lines get cleared and stuff like that. It's very nice and clean and simple. So what we can do now is if we refresh this white background should be gone and replaced with gray tiles. Let's see. Nope. Tetromino draw. You don't have a tetromino. Why don't we have a tetromino? That's weird. Let's see. So our window we have board. We have tetromino's color is NaN. We got not a number. Our tetromino color is not a number. Why did that happen? So I think I just did this wrong. Yes, I did. Shape's length. I tried to multiply an array by a random number, and that's what you get. There might be some other problems in here, but at least we can fix this one. One step at a time. Okay. Tetromino is still undefined for some reason. Again, I'm thinking in terms of other programming languages. We need to use the keyword this, because we want to say not just any tetromino, we want to say the tetromino belonging to this instance, which is this fellow here. It will be this fellow once we actually declare a board object. Okay. Proper good practice rules. Okay. We're close. It's still black, but we're closer. If I refresh, we'll get rid of that error again. Okay, cool. I don't know why it's black, but I can find out. So let's go back. Let's investigate my broken code. So we're calling board.draw, which goes in here. This tile is draw tile, image data XY. This tile's I should be the color, right? Draw tile takes the color number, and 0 should be these colors, the grays. Data index. Are we doing this the same way? Tiles I. Oh. So this code looks the same, and it shouldn't, because the tiles on the tetromino are the position of each tiles. The tiles on the board are the color of each tiles. I should have remembered that. So what we actually want to do is, instead of this tiles I, we want to do just I, because I is the current index on the board that we're looking at. And, it starts at 0, then it goes up through 1, 2, 3, 4, all the way to 4,480, I think, for our 40 by 80 canvas. each one of those we can convert it into an x and y coordinate, and that's what this is supposed to do, and now what it actually should do. So let's watch the white tiles appear. No, they don't. They still don't. Why is that? Let's put a breakpoint in here. So, x and y is 0. That sounds good. This tiles I. We do tiles. I is currently 0. There are 200 of them. Tiles. Oh, tiles only has a length of 1. Why is that? Wait, why does tiles only have a length of 1? I think I instantiated my tiles array incorrectly. I will have to investigate. I do that. So when you declare an array object in JavaScript, you can put the curly bracket, the square brackets in there, and that will convert the contents. Like this defines an array with the square brackets. And then if you put it in, if you pass that here into this array, you'll get whatever this array was converted into a unsigned array. But if you don't put the brackets in, then you're saying, hey, look, I want an array with this many elements in it, which is what I meant to do, and I typed it out wrong. So that should be correct. I don't know. I'm still not convinced that it's going to work after all of these mishaps, but maybe it will. Hey, there it is. Look at our nice white tiled background and our little tetromino sitting up there. That's what I was trying to do this whole time. All right, cool. So we have some of our rendering going. Let's hop back into the script. How much time do I have? I've got about half an hour before I'm done. I can at least make the tetromino drop, and then it'll stop at the bottom. So let's do that. What we want to do is we want to get into our rendering loop. And yeah, no, we do have to make the rendering loop, don't we? Okay. So all this stuff, we can indent it, and we're going to make a function that I always like to call it frame step, because this is going to be every step of the way that we go. And it's going to receive a timestamp, which is kind of an arbitrary number that will help us determine how much time has passed since the last frame step, which is very important. Why do I have... let's see, let's actually move these down closer to their... to where they get used. I feel like having them so far up here is a little funky. We should have them down here. Oh, and you know what? I did this wrong. We should have a function that's just called render, which when we call it, we're going to render an image to the screen. So our frame step, though, we're going to have to do some stuff with the frame step. That's going to be nice and neat. We're going to track the last timestamp, which I'm going to set to -1 to start because I'll explain why. And I'm going to just type up a whole bunch of stuff without comment and explain it in a second. Because this is where recursion comes in. Quasi-recursion. It's not literally recursive. Okay, and then we want this. Okay, cool. No, we don't want that. Okay. And, yeah. So what we're doing here, this is how... So we did the canvas stuff. Make a canvas element, grab the context. Make a canvas element here, grab the context, and that is how you draw stuff. If you want to draw complicated stuff, you know, programmatically from a script in the browser. Draw stuff in the canvas. This is how you do updates every time the monitor, excuse me, every time the browser. Oh, I didn't even do this right. It's request animation frame. That's it. This is how you make an update to the canvas object that we have every time the browser does like a frame draw. Every time it redraws the screen. This usually correlates to the user's display refresh rate. So like 60 hertz is a pretty common one. You would have 60 times every second we're going to draw something. So this function is what we're passing in here, and this needs to be as efficient as possible so you don't slow down your computer. This is basically this type of function, this our game loop. This is effectively our game loop, but I've called it frame step because it's each step that we have to we get a new animation frame. This frame step is going to get called as much as 60 times every second, maybe even more, which is very taxing if you're doing lots of complicated stuff with if you're doing lots of heavy lifting with your software, like big 3D games will do. That's why you need a big beefy gaming computer to do some more modern games. So the first time we call frame step, there's going to be no timestamp in there. Actually, you know what? I'm going to say if timestamp. No. That's wrong. What we need to do is this. We need to call request animation frame to start everything, and then each time function is completed, we call request animation frame again. And so what are we doing here? So what happens here is every refresh time when the browser is going to draw everything, it goes down this whole list. I'm going to explain what delta is later, but every time we call render, because potentially the thing has been re-rendered. But we can optimize this because this is Tetris, and Tetris isn't really active if you're going back, if you're being retro like I am here. And then at the end of all this, we call this again. And this looks recursive, but it's not really. Because what this does is this adds the frame step function call to JavaScript's queue, and it'll get called later. It'll get called later on in the queue. It's not technically recursive because this this animation frame event might not take place. Like if you're in another tab or something, it might not happen. So we're going to have to mess around with the delta, and probably if the delta is too big, then you probably want to like clamp it down. Because if somebody leaves a tab and comes back, then the time between the last frame step and the one when you just came back into the tab is going to be huge. You're going to have things like animating super fast. So this won't actually look any different from before, I think. If I didn't make another typo or another mistake, this should be fine. This will look the same. But now, every time the browser refreshes, we're drawing the screen again. And we need that in order to make the tetromino fall. So what we're going to do is we're going to give the tetromino a new method. Tetromino prototype. We're going to say drop. Yeah, I'm going to say drop. And doesn't take any arguments. And what we're going to do is for var I 0 I less than tetro count. We have to do this a lot in this way of writing things. We're going to do this tiles I plus equals tet board width. Oops. Good grief. There we go. Simple as that. All we do to make the tetromino drop one row is to add the width of the Tetris board to each tile. Super simple. Trick is, we don't want it to, if we can make it drop every frame actually. If I do that, let's do that. So we should probably, we should add a process. Let's say, to encapsulate everything, let's say tetromino prototype. We'll also say process. or whatever. I'll get to that in a minute. For now, I'm just going to show the quick and dirty thing, which is board tetromino, because we can access the tetromino from outside the board. Drop, and it's a horrible mess. But you're going to see, don't blink or you'll miss it. My monitor refresh rate is pretty high, and as soon as I reload the page, we're going to get a new tetromino, it's going to go whoop, and it's going to fall off the page. It's actually probably going to glitch around a lot after it passes the bottom of the screen, just because of the way that we've configured everything. The numbers are going to be out of range. So we might even get an error up here. So 3, 2, 1, 0. Oh, look at that. Boop, boop, boop. And it's glitching all over the place and it stops. Probably it hit too big a number and now it's just clamped in there. So what's going on there? It's real simple. We're dropping the tetromino one row every frame, and we don't want to do that. Instead, we want to have a function we call process. We could probably do this. We want to have a function we call process. Oh, you know what? Process. We'll write a separate function called process. And oh no, you know what? The board is the only thing we're processing right now. If I need process for other stuff, we'll make one. But we're going to make a method on the tetromino board. Tet board, proto. Oops. I forgot. That must be an autocomplete that I could be using. We're going to accept the delta as an argument. I like to put all these things in alphabetical order, even though maybe that's not the easiest to find, but that's what I'm doing here. We're going to say tetromino drop. In the process, we're going to say tetromino also process. Process. All right, and then the tetromino, we're writing this function. So what we want to do here, all 6 of the delta, is we want to call this to drop, but only after a certain amount of time has passed. And we can track that in our tetromino itself. So this dot drop countdown, we're going to say it's equal to we don't want to start it at 0 because it'll drop right away. What are the drop delays? I have I did look up, as I have many times for this with this challenge. I have looked up what the dropping speeds are for tetrominos in Tetris, like the official numbers, and they look like this. Oh, also let's also move you down so you're alphabetical. They look like this. Drop delays at level 1, it's 900 milliseconds, and then it goes up each level. So drop time down, we want to do drop delays length -1. Oh no, that's wrong. We want to do the first one. We want to do 0. Or not even. We want to do, well, we want to do 0 for now. We should initiate this tetromino with the current level that we're on, so that it starts off with the drop delay relevant to the level, but for now we'll do 0. Because I've got to ramp up, I think, soon. Oh well. I had a feeling I wouldn't be able to make this whole thing in 2 hours, but I got pretty far. So what we're doing here is in the tetromino process, we want to do this dot drop countdown minus equals delta. And our delta is going to be in milliseconds, I think. Let me double check, because I think the timestamp is in milliseconds, right? Yeah, timestamp is going to be in milliseconds. So our delta, the current timestamp minus the last one, is going to be the time since the last frame step in milliseconds. And we pass that delta into here and subtract it from our drop countdown. Basically, what this delta does is it allows us to track how much time is actually passing while the game runs. Because the old way you used to do it is if you had like a Nintendo Entertainment System, if you had an NES, you knew that it was always going to render at the same frame rate all the time, and it was going to be a constant frame rate. You could just be like, okay, every time we call our frame step for, Super Mario Brothers, it's always going to be, that's a bad example because they probably did use something smarter like this, but for example, Tetris on the Game Boy Color. Every time we get frame step in our Game Boy Color game, sorry, Game Boy Pocket game, we know how fast the Game Boy renders the screen. We can just be like, whatever it is, like, 0.1667 or whatever fraction of a second it is. That's how much time has passed each time we draw stuff. In the browser, everybody has different displays. Things are going to speed up and slow down, so we want to calculate what the actual time is, and that's what this is. That's what this delta is. The delta is the actual time that has passed. And so each time we call process is going to be each time the display has re-rendered, delta amount of time has passed, so we subtract that, and if drop countdown is less than or equal to 0, then the countdown has expired and it's time to drop. And we do this, drop countdown equals this, for now, we're going to have to change this later. I'm saying that as if this stream is going to go on long enough for it to actually do that, but you would want to change this later so that you do drop delays and, like, level, whatever the level number is. But for now, I'm going to do 0. So we drop the tetromino, change the drop countdown. Nice and simple. What I should do is after we drop the tetromino, the Tetris board should check if the tetromino has hit something or hit the ground and stop it. For now, we're just going to make it drop at the correct speed. So here it's started up again, but now I'm going to refresh, and we have an error. Oh, because I forgot this again. That sneaky this. Okay, is it right this time? Only it's right this time. Refresh, please. Why am I not refreshing? Oh, don't tell me there's like a Stack Overflow error. Let me get rid of these. What's going on? The debugger is still triggered. Might have a little bit of a technical problem. Let's see. Firefox is not eating a lot of memory. Here. Hmm. So maybe nothing's happening. Let's see, if we put a breakpoint. Oh, I can't interact with anything. Is this just broken? Yeah, I think I must have screwed up something somewhere. The gesture board drop. Oh wait, now it is working. What? I left the window and now it's working. Okay, weird. I guess maybe it's just OBS is eating up a lot of processing power or something. Check my task manager and see what's going on there. Yeah, what is this? I'm getting a CPU spike. Okay. But look at that. Let's refresh so that we can see it from the start. So now, this looks a lot more like Tetris, doesn't it? It's not, dropping and spinning all over the place. It's just slowly dropping down to the bottom. I'm not sure if this is actually the correct starting position for the line piece, but feels right. It made sense in my head anyway. Now it's going to, of course, go crazy and go all over the place slowly. But we have it dropping. Player control is the other main thing in a video game, any video game. So let's do that a little bit. Let's at least get that in so that this is a little more complete. Tetramino. Oh, you know what? I'm going to do proto. If I do proto, then I can do this. Okay. Tetramino. And we can say Tetramino prototype, we're going to say slide. And I'm going to have, my argument is going to be right. So if right, we're going to do does that make sense? I'll say direction. So direction is going to be either 1 or -1. We're going to do, I'm just going to copy this because I don't want to type it again. And we're going to say this dot tiles. And for each tile, we're going to check if it is, oh, that's right. Okay, so we're going to say, we're going to have to make a complicated conditional here. If direction is 1, so if we're going, or let's say -1. If direction is -1, so we're going left, and this tile's I equals 0. So if we're trying to go left, and the tiles, oh, excuse me, this tile's I, we're going to do modulo. Jet board width. So here's our first conditional. It's complicated, but if we're going left, if we're trying to slide left, and tile position, tile X position, which is our modulo width, equals 0. So if we're in the 0 column and we're trying to go left, then we want to return false. Because that's the thing I'm going to do. I think for this one, return whether slide was successful. We're going to have another similar condition. We're going to say or direction equals 1, so we're going to the right, and this tiles I modulo Tetris. Maybe we should just get the Tetris, maybe we should just get the X position here, Rx. If we're gonna, oops, if we're potentially calculating the X position of this tetromino tile twice, so let's just get it the one time. So if we're moving to the right, and this position is equal to the Tetris board width -1, which is not how you spell width. If it's equal to the Tetris board width -1, which that would mean it is at the farthest to the right column, then we also return false. It's a little annoying, but we have to do these checks. Oops. We have to do these checks before we move the tetromino piece. Because if we don't, then we'll shift it to the right, and the block will appear on the next row at the start of the column, at the start of the row. It'll be a whole horrible mess, but then we can return true if we don't trip up any of these conditions. So then, this dot tiles I, very simple, plus equals direction. That's why we do -1 for left and +1 for right, because we're moving it left or right. Left or right basically moves it left or right along the direction of the array. So left being smaller index number and right being a bigger one. And you'll see that this works in a second. In fact, to demonstrate it without having to code the rest of the things, let's do this to slide 1. So every time we drop, we're going to slide to the right, just to make sure that it's working properly and that it stops when it reaches the far right. So we're going down and to the right with each drop, hits the edge, and it stops. Nice and easy. I'm going to toggle it to -1 and make sure that it's checking properly that it doesn't hit the left either. Oh, look at that. It even picked a mirror piece by coincidence. So there we go. We're trying to move to the left, but we've reached the edge and we stop. Oh, excuse me. Having an upset stomach. So, now back in the program. I'll try and just add real quick some user input to make this work. So the way that this works in old Tetris, all the old games that I've played, and I don't like this way, but I'm going to do it because it's fast. Let's scroll all the way down. What we're going to do here is we're going to say, we need to have the board declared first. So the board needs to be up here, and then we're going to make our, what are they called? We're going to make our event listeners. So we're going to say document, add event listener. key down, handle down. And I could write this as a closure. Oops, I'm just hitting extra keys. And then we're going to do that and handle key up. So we need to handle key down and key up. I'm going to keep it super simple, although ideally you want to do like a more involved system that allows your users to that would allow your users to change their key bindings and things, dissociate the action that you want to dissociate the action you're performing from the literal key input that you're doing, or mouse input, or gamepad input, like analog stick things. So anyway, we're going to do switch. We're going to do a switch case. Case, arrow. I'm going to use the arrow keys. Arrow left. And we're going to say board tetromino dot slide -1. Case, excuse me, case arrow right. But yeah, the other problem with this is that if you press down both keys, at once, technically one of them will be pressed after the other one. Oh, we don't need the key up if I'm doing this, so let's keep those out. This way, you press down the key, and then once the repeating signal comes out of your keyboard, it'll keep sliding, which is kind of how old Tetris games used to work. On modern computers, it's not great because that repeating signal can be very fast, and the delay between the initial key press and the repeating key press is going to be too long for most people to be happy with it. You'll end up mashing the key rather than holding it down. But that is actually the simplest way to do this. It's not my favorite, but I've only got a few minutes to show it, so let's do it. We're just dropping like normal. And I'm pressing the keys and it isn't doing it. Oh wait, is it arrow left or left arrow? No, it's arrow left. Oh, hang on. Me and my big ego forgetting how to type these things. The event is the whole event object. Event key is a string that tells you what the name of the key was. Some older browsers do not support this, but they're so old generally that we don't worry about them. So there we go, left, right, left, right, left, right, left, and I hold left, and right, and I hold right, and it looks like that. Actually, that's not, I don't like it, but it's not terrible. It actually feels a lot like the way the Game Boy version played. There you have it. Let me reload that again. There you have it. Very, very basic implementation of Tetris, missing a lot of stuff. But I didn't even show it off. I still had the anim window open. Okay, let me show it again. Press left, press right. Maybe you can hear the key clicks. I don't know how loud they are. My keyboard is very noisy. But look at that. Zip, zip. Nice and simple. Rotation is much more complicated, as you might expect. But it is doable. Yeah, I think I have to call it a night for now. But I'll leave you with that. And maybe I'll post my script somewhere. I could put it on GitHub or something. Maybe a gist. Oh, you know what? I'll put it on what's it called? It's one of my links. It's one of the links in my profile, and I can't remember what it's called. Where is it? The gosh, it's the site where you can put up any CodePen. That's it. The link is in the about section of my channel page. So go to my CodePen, and you'll see this up there. You can investigate for yourself. You can manipulate the code all you want. This particular instance, I'll try and put this up there soon, maybe tomorrow. Unless I think the full version or the like more complete version that I've already written is up there already. So for now, I got a split I should eat dinner because it's pretty late and I didn't eat. And I'll be back on Monday with a new time, 6 p.m. Eastern Standard to 8, because it's daylight saving time, and I have a weird thing about daylight saving time, so I'm doing the streams earlier for now. I hope to see you there. It's going to be Monster Hunter 3 Ultimate again, doing some more low rank stuff, and maybe the Sea Deus Ultra Dragon. We'll see. But until then, thank you for joining me. Maybe I'll come back to this Tetris thing later and do some more of it. For now, I bid you good night.